Hello everyone. So to continuing our discussion on the time series data, let's deep dive into our other few subtopics. So I'm just load the libraries and we are going to first discuss period and period arithmetic. So what does it mean by that? As a frequency, you can put multiple periods which start with like 8 December, that means the year end. And let's see what is so in this PD dot period, which is with a capital P, and this 2011 represent the full period of year end, right? So if I do plus 5, so that start with 2011 plus 5, 2016, minus 2, 2009, right? And again, if if I do the 15, 2015 plus a December, that means that 4 multiplied by the year end. So I'm doing the minus of it. So 2011 minus 2015, what is it? The 4 years gap, right? You can do a period range. So period range, you have to use pandas dot period range, the start and the end and the month. So it will be like January, February, March, April, May, June, right? Year and the month. And the period is month. You can use this as the index, and this is the time series which has index as the years and the month. Next, if we look at the period frequency conversion, so again, we'll start with having this period with 2011. It's this till the year end, right? So if you want to see when this is starting, right? So you can see as frequency, period means p dot as frequency within the as month, show me as a month and show when it starts. So it starts with 01 and it's at with 0 12. So as I tell, this represent the year end. So we are, this is a period of 2011 and this is the pictorial representation. So this is a period of 2011. A December means till year end, right? It start with January, it end with December. And if I say period 2011 minus 6, so this represents June because it's we are asking for a month, right? And let's move to next. So you can also do a period range by only assigning the years in this 2006 to 2009 and a December again, which is what the year end, right? And let's use this as the index and normal values of photo 2006, 7, 8, 9. So that's what the our range 2006 to 2009 as the year end. And again, you can check each period will start with the first month and each period will end with the 12th month. Quarterly period frequency. Again, in timestamp, you will, if it is the financial data, you will also have a lot of quarterly data. And that's what is, you can have multiple types here. So the pandas dot period, this is a 2011, start with quarter 4 and frequency is Q Jan. So what is meant by Q Jan, right? So let's see. So it start with January. Uh, so it start with November and it end with the January. So that's the quarter end of January. And similarly, we have other three types. So these are the months, right? Q December means it start with this will be your first quarter, second quarter, third quarter, fourth quarter. If it is September, so September to to December will be first. This will be second. Right? This is the first. This is second. This is third. This is fourth. And Q Fab means the Q December will month will be the Q4, and the other two Q4 will be Jan and Feb, right? And then it start with December and followed by other 3 months like that. Converting timestamp to period and back. So you can change the times using the timestamp. You can change to the periods or vice versa. So let's create a date range with 2000 with period 3 and months. So only January, February, March, and use this in our time series. So it says month because it's a January, it's a February, and it's a March, and these are the random values from standard normal. And I want to convert this TS to period. Okay. So what is mean by the period? Only the years and the month, right? And let's start with January 29th and the period says, so by default it will take as the day, right? And so this is 29, 30, then next month I'll start it and use this into create a new time series called TTS2. So let's start with the January 29, 30, 31, then the February, right? And now let's convert this to period months. So what do you think it will be? So there are 2 months here, right? So let's start with, so this belongs to January and this belongs to February, three readings. And if you want to convert this to, this is the same thing of the days, right? Here you can see the frequency is days, above the frequency was month. And you can convert this part to timestamp and how you can end. So what this means by it start with again the date is same, but it also have a timestamp of the last hour, right? And the end hour. So you can also make the start, right? Let me creating period index from array, and this is which I have seen earlier also. So we have a macro data, financial macro data, the year, quarter, right, and all the other variables. And now we can see, okay, this has a year data also, this has the quarter data also, and we can combine year and quarter, like year 51, quarter Q1, Q2, and that can be achieved using the period index. So pandas dot period index, you provide the year data, you provide the quarter data, and the frequency is Q December, right? So that's the index, and you can use data dot index to this. Now instead of index 10123, it has the Q5, Q1, Q2, Q3. So all your quarter and year is combined and created as the index here. Resampling and frequency conversion. So resampling we discussed in the last video. Also, resampling means you can convert your frequency, the indexing if it is from days to month, months to days, and there are two types: the downscaling resampling and the resampling. So let's see that. So this is a date range. We start with 2000, make it for 100 days, right? And use this in our time series. And now because as you can see, the index is in the days and we want to convert into the month. So provide your time series dot resample and m represent here months and give me the mean. So as you can see, this goes till how many? 4 months, right? So it starts with January till March, April. And the mean of each month is represented here. You can also provide the kind period you want to convert period, but if you're not providing, it's still producing the same result. Now this, let's first see the downsampling. So downsampling is aggregating from higher to lower frequency. So what it's happened in downsampling, it first divide your data into the beans and slice and then convert it. So let's create a date range from 01 to 12 and T represent the minutes. Okay. So these are the each minute, right? Create a time series and now converts the 1 minute into the 5 minutes, right? So you have to just provide 5 minutes and sum. So there is one more parameter here closed, which represent at which end you are including the reading. So let's say you have a 5, 0, 1, 2, 3, 4. So are you including 4 or are you including 0? So to do that, you have to use closed where you are closing the that bin. So like in the histogram, right? You have a you start and your end, and the exclusive the bracket represent the square bracket represent you are including that value. So similarly, so if we start put the close as right, so it goes one. As you can see, we created the series with 2001, but it goes will 1990, 12, 31, right? And similarly, you can put the label also to right and left, and it will change the indexing in the correct manner. So if you are aware of the stock market, you might be aware of the open, high, close, low. So the stock price of any ticker will have something. It's start with some value, and throughout the day it make a high, it make a low, and that is closes, right? So it is same thing, open, high, close, low. So let's create one time series. It is based on the indexing, right? We have it in the minutes, and these are some of the value. And now let's resample this and also put this into the OHLC function. So what happens here? It divided this data into three 5 minutes brackets, right? 0, 5, 10, and then added open, high, close. So if I go 0 to 5, right? So this is the one, right? And it is not including the 3 here. Okay, so 25078. So what is the maximum? Maximum is 8. What is the open? It's 2. And what is the ending? 8. What is the low? 0. So that's how, without doing any much writing a big code, the Python has already provided this function of SQL to do that. Upscaling. So upsampling represent the converting your lower frequency to higher frequency. In this case, this does not divide data into bins. It automatically created. So let's create one data frame of 2 by 4. It's the date range is 2001, period is 2, and the frequency is week Wednesday. Okay. So this is what the data frame looks like. The first variant is 05, the second variant is 12, and you can convert this into days, right? So as you can see, the days there are the between one Wednesday and the next Wednesday there are empty data, right? And you can fill this data using F forward fill. So all this value will be cascaded to the below, right? And so that's what the upscaling. So you convert your higher frequency to the lower, right? Sorry, I told it lower frequency to the higher one. So weekdays to the days. Resampling with the period. So let's create one data frame, right? We have 24 by 4. The date range start with first month 2000 and to the 12th. So it's 14, right? 24, 2001. Month is some frequency based on the month, and column is A, B, C, D. We can resample with A dash means divide into the year level of resampling, right? And that is, and we are also getting the mean of each column here. You can do the QDS, right? Quarterly and quarterly of March. And it's again, it's provide the forward fill. Next, we'll look at some of the moving window functions which represent the you have the calculated values based on the previous value. So we have a stock data here of Apple, Microsoft, ExxonMobil, right? These are the time index is the times, and these are their values. And let's see so what we are doing here, we are resampling based on the business end, right? And if any values are none, we are for filling it. And let's plot the chart of the Apple. So this is what the Apple looks like in 2003 to 2012, the significant growth in the stock, right? And now let's see what is the rolling 20. So again, we are going to plot the same data, plus we are going to do or call the rolling 250. That means give me the rolling means cumulative value, average value of that, and let's plot that. So in the next this plot, you can see the blue represent the actual close data of that particular day, and this is the average line between with during that whole time series, right? 2003 to 2000, and this is the value. So this is the average value of moving average of 250 days. You can have the standard. So in this, we have the same thing. We are just checking the percentage change. and the rolling window of 250, minimum period is 10, and to calculate the standard deviation. So this is the standard deviation looks like, and if you plot this, it will give me during during that year, particular year, what is the standard deviation value of that particular stock in this Apple, and what is the standard value, right? You can see the from the mean it goes to 0.10 till 0.035. You can also calculate the expanding mean. There is a function called expanding, and it will give the results. Also, if you want to calculate rolling for all, so you can just like this. So as you can see, the Microsoft and the Exxon Mobil, they have a very uniform or linear growth. On the other hand, the Apple was growing almost like the exponential growth. We can convert this into this axis, the y-axis, into the logarithmic, while log y equals to true. And lastly, just if you want to calculate the rolling 20-day, you can just put down this value, and each value is calculated as the rolling value, rolling average mean value of all the data, all the columns available in the data frame. Similarly, as the rolling, you can have the exponential weighted function. So let's get the Apple data from 2006 to 2007, and let's create the moving average of 30 days and exponentially weighted moving average of 30 days, and let's plot this. So this is what the value looks like. So as you can see, the exponential weighted moving average is more aligned toward the actual compared to the simple moving average. Next, you have a binary moving function. So here we are calling the separating the SPX index. Percentage change, we are just how much percentage getting changed from the previous value, and return of all the three, right? So let's do the correlation between the Apple return of rolling window of 125 days with the SPX returns. And if you plot that, you can see the correlation between the apples and the SPX returns. It's fluctuating, right? In terms it is very less, but in the other, it is highly correlated of the SPX returns. And you can do it for all three, right? It's a bit busy chart, not giving more insight, but you can, if you have multiple tickers in your dataset, you can do that. Also, you can have a user-defined moving function. Let's have the percentile of score. Means it's a 2% rank of the 2% of the Apple return over the 1 year window. And if you result it, so as you can see, the percentile rank of 2% of the Apple return over 1 year window. This is how it looks like. And if you want to get more information about the SciPy stat percentile of score, you can, of course, you can put the question mark, and it will give you all the results. So percentile of score, it's compute the percentile rank of the score related to the list of the score, right? So for example, 80% mean that 80% of the score in A are below the given score. So that's what we deviated toward the financial data, but we are going to discuss a lot of other examples. And before we end this data analysis series, so stay tuned. Thank you all.